Okay, so let's move on now to 5.3. We've talked about this idea of polynomials. You looked at that yesterday with division of polynomials, and then the day before that with our properties of exponents and whatnot. And the idea of polynomial is nothing more than just it's a combination of terms that contain numbers and variables to different powers. So what we're going to look at today is how we evaluate those given a certain situation, and then we're going to identify what happens to them. And the reason we do the identification, the shapes, it can give us a trend of what's going on and see how different polynomials of different degrees behave as they move throughout the coordinate plane. So that's where we're going today. Let's start number one, this first video. Let's talk about how we evaluate polynomial functions. We're going to get to this one over here in a minute. But let's start with something real basic. Let's say, for example, I have simply, g of x equals x squared plus 5x minus 2. Okay, it's a quadratic. It's got three terms. X is my variable. And if we go back, we've looked at situations where we have finding g of negative 2. Now, a couple reminders. This is not g times negative 2. All this is information for me. G is the name of my function, and negative 2 is what I'm evaluating my function at, meaning that's the value of x. I look at what's changed. G hasn't changed, but the x has now become negative 2. So essentially what this is saying right here is that x equals negative 2. And in the past, we know that if we have equality, we can swap things in and out. It means wherever I see x, I can replace with negative 2. So I'm going to come up to my function and plug negative 2 into my function. So there's an x, so that becomes negative 2. Then I have a squared plus 5 times, there's another x, that becomes negative 2. And then I have minus 2. So that's evaluating. Again, this isn't going to change it because this is simply information. This is telling me what I'm using and what I'm doing to that. Well, if I evaluate that, that becomes positive 4 here, because negative 2 squared is positive 4. Minus 10 there, that's 5 and negative 2, and then minus 2. So if I take my function, g of negative 2, again, this is not g times negative 2. You might want to write that down for yourself just as a reminder. This is simply information. We're not going to do anything with it. And then here, 4 minus 10 minus 2 is actually negative 8. So that's your final answer right there. I can go no further. That's it. This is telling me if I look at function g, which is right here, if I plug in or evaluate that function at negative 2, meaning make x negative 2, my result will be negative 8. Okay, now remember, g of negative 2 is just like y, so this is actually the ordered pair, negative 2, negative 8. That's really what this means in the grand scheme of things. Is I had an x, I plugged it in. G of x is the same thing as y, so I can say it's my y coordinate as well. So that's the basic idea of what we're looking at. What we're going to look at today with this problem over here is, well, what if I put some unknown quantities in there? Okay, besides numbers, what if I put some variables in there? Well, we still approach it the same way. We just have to be careful. We're going to bring back what we talked about in section 1 about multiplying polynomials, so you have to be careful of that. So going to this next example here, find f of 3c minus 4 minus 5 times f of c. Well, here's f of x, function f, so I have f, bad arrow, sorry. I have f, and I have f. So those are the functions I'm using. Remember, the stuff inside is what is going to replace x. So in this first one, let's take it just piece by piece. This first one, this says that x is equal to 3c minus 4. That's what the stuff inside means. So that means wherever I see x in my general function, I'm going to replace it with 3c minus 4. So let's start with that. All right, so f of 3c minus 4 will equal, again, wherever I see x, I'm plugging in 3c minus 4. 3c minus 4 squared plus 2 times, there's another one, 3c minus 4 minus 3. Now it just becomes some cleanup. Now remember, we talked about this yesterday. When I have subtraction to a power, I can't apply my properties of exponents to that. I have to actually multiply this out. So throw it on a little box, or if you can multiply it out in your head, that's great. And we set it up as 3c and negative 4, 3c and negative 4. So do that, go through the multiplication. What you'll get out, you'll get 9c squared, and you'll get minus 24c, and then you'll get plus 16. Okay, that'll be my, my result of that part. Then I have plus, I'm going to distribute the 2 into here. So it'll give me a 6c, a minus 8, and then minus 3. Well, that's part I need to clean up now. So like terms, 9c squared is the only c squared there. So that guy's his own. Next are my c's. Remember, I'm going in decreasing order for my each term. So power of 2 is the highest. The next will be a power of 1. So negative 24 and positive 6 is a negative 18c. Then I have my constants. 16, negative 8, negative 3. So if I do 16 minus 8 minus 3, I'm going to get a positive 5. So that's this first part. So f of 3c minus 4 is this. All right, so that's what this part is up here. Okay, now I have negative 5, or this guy, minus 5 times f of c. Well, again, now my second part, so I'm kind of going back to the beginning again, and I'm going to start over with f of c. So now x is equal to c. That's the second part. This first part, f was equal to 3c. Now x is equal to c, because that's what's been replaced x. So wherever I see x, I'm going to replace it with c. And then it says multiply it by 5. All right, so let's do that. Well, here's my function. If I replace that with c, I'll have c squared. If this in red, so it sticks out. C squared plus 2 times c minus 3. Well, that's nothing. I can't combine those. That's it. So this becomes c squared plus 2 times c minus 3. Now you might be asking, where did I get this 5 from? Well, remember, that's part of my original function right here. This is the whole thing I'm looking at. So I'm trying to evaluate. I'm doing the function twice because I have 2 different values that have been replaced. And then it says, take those ideas, subtract 5 times the second one from that. Well, here's 5 times the second one, so if I distribute that in, remember to watch your signs. Move this stuff down here a little bit. Okay, so I will have 9c squared minus 18c plus 5, and then here I'll have minus 5c squared, a minus 10c, and then negative 5 times negative 3 is a positive 15. And once again, this becomes an idea of using your order of operations and figuring out where we're going. So c squared's cool. That becomes 4c squared, because 9 minus 5 is 4. Next is my c's. Negative 18 and negative 10 is negative 28c. And then I have a 5 and a 15, both positive, so it's a positive 20. So my final result, f of 3c minus 4 minus 5 times f of c is going to equal this guy right here. All right, so that's our whole piece of the pie right there, just bringing everything out. It's a matter of taking the first portion, figuring out its value. We did that here. Taking the second portion, figuring out its value, and then doing what it asks us to do. Go ahead and combine them into my final answer. Okay. So that's that first part. That's the idea of evaluating polynomial functions. All right. The rest of the video, we're going to look at kind of identifying shapes and stuff and what those mean in terms of our graph. So the next one is going to be a lot of information. So in the next video, you probably want to pause it a few times to make sure that you're getting down the information you need as I talk a little bit, and then go back and watch it again. So that's the application portion of what we're looking at. Now let's look at what is going on with the different parts of the polynomial.